Good morning, everybody. So, show of hands, who has had work boots that got muddy because you worked on a nuclear facility construction site? All right, that's good. It's our audience participation part. So I want to talk, when I thought about innovation in construction, the first thing I thought of is what is success? And my definition of success in construction for nuclear is what I call the 3 Ps. And the 3 Ps is the concept that the people, the parts, and the paper all have to be developed equally to meet all of the appropriate requirements, at the level of quality required, keeping safety as a top priority. So if you can imagine an egg sitting on top of this 3-legged stool, all those pieces need to be there to support that egg in order for us to be successful. So these 3 Ps have to be choreographed to arrive simultaneously at a usually very specific point in space and time. If one piece is missing, if a person's qualifications is not quite up to snuff, if the part doesn't have the right pedigree, if the print is wrong that we're working to, then the effort falls apart and you go back to the shop and start all over. And this causes us delays, which result in project overruns and additional costs, as we know too well. So in construction, then much has to be done before showtime, like a football play or like a ballet. You can't just say, hey, everybody go along, and I'm going to throw it up to whoever's open, or to the ballet dancer, hey, go out there and just shake it as good as you can. You got to have early involvement of the people that are going to actually be out there doing the work, and that means early construction focus on a project. So what are the innovations that are happening today? One of the big ones is integrated suites, tools of information management. So this is really about big data. It's taking a 3D model, integrating that with your materials management, with your schedule, and really simulating first before you go out to the field and run into problems. So you simulate that first, and by doing that, you eliminate the errors that you might see in the field where those 3 Ps don't come together. Another innovation currently ongoing is modularization. And here, you can go and assemble a big part of the plant in parallel with what you're doing critical path in the field at the construction site, and then transport that to the site. So you save some critical path time. And there's a whole bunch of potential savings that can be reached by modularization. But you can get the field staff down at the construction site. You can shorten your construction schedule, and you can get an appreciable savings in the total installed cost of the project. But any modularization, there's no such thing as a free lunch. So your savings that you might get in field labor costs, in critical path construction, and maybe improvements in quality and safety are offset somewhat by the need to do early engineering, much more engineering than you would have had to, planning transportation, which can be very tricky, and then improving your site with craneage and whatnot so that you can actually install those modules when they get there. So more is not always better in modularization. Another innovation that's happening in construction is digitization in the field at the job site. And real-time data collection, the use of RFIDs on parts is really helping out because you're not losing your parts. As the picture shows, you can go to a snow-covered field and go directly to the part you need, get it quickly, and get it to the site on time. Again, helping you with the 3 Ps, doing that efficiently. So what's happening in the future? Don't have a lot of time, but lots of potential things. Drones are helping with aerial photography and progress. High-tech materials, stronger materials, concrete, rebar, use of lasers and GPS to measure, improve your measurements. Automated welding, automated driving vehicles, and wearable technology. So imagine going to a particular site construction site, and your hard hat has a heads-up display that shows the 3D image of the piece, the work face that you're trying to build. So, you can really overcome a lot of problems, but the hard hat with heads-up display doesn't come cheap. So lots of potential. And one thing I want to point out is that with any new technology and any innovation in construction, you have to consider the timeline of the development of the technology, when it's going to be proven, is it going to be implemented then in the consensus codes and standards like ANS, ASME, IEEE, and then after that, when is it going to be accepted by your regulator so that you can actually use it in construction? And those things must meet your assumed timeline for your project. So I was reading, last night, I didn't tell you, but I'm also the president and CEO of the Mark Paris Micro Mini Modular Power Source that's going to be in every home one day. And I was reading an article that somebody had come up with this material, unobtainium, and you can coat it with impervium, and then it's joined by a fusion-powered proton welding machine in the field by one person. So they said, though, that the technology is about ready for development, to deploy, but my staff of my wife has said that we can have our reactor design, we can sell it. The NRC is going to take 2 years to license it, so that'll be 1 year to design, 2 years to license, and we'll be building it in 3 years. So I don't think the unobtainium coated with impervium is going to fit our timeline for success. So the bottom line is lots of things happening in innovation in construction, but each project has unique aspects that have to be considered for implementation of that innovation. And sometimes, the old hammer and the old saw are the best tool for the job. Thank you.